So, chapter 28, problem number 37. And at first blush, it looks pretty simple. It says, what value resistor will discharge a 1.0 microfarad capacitor to 10% of its initial charge in 2.0 milliseconds. Okay, so with this question, we have to find the value of the resistor that will discharge a 1.0 microfarad capacitor to 10% of its initial charge in 2 milliseconds. So let's go ahead and start off by drawing our RC discharging circuit. So we have our capacitor. We're going to assume that our capacitor, it doesn't tell us what the value of the initial potential difference is. So I'm going to just write that over here, the initial potential difference of the capacitor, and I'm going to leave it as a question mark. We don't know, but that might be something we need. Also, they do not tell us the initial value of charge on our capacitor plates, but that's okay. I'm just going to file it over here and leave it as a question mark. And let's go ahead and indicate the initial potential difference. And so we have this capacitor in combination with this resistor. And we know that if we say the upper plate is the positive plate, there is going to be a current flowing in this circuit. This current is going to vary as a function of time, along with the charge on the capacitor plates varying as a function of time, along with the potential difference of the capacitor plates varying as a function of time. We want to know when the charge, so I'll say Q, is equal to 10%. So I'll say 0.10 of its initial charge. So, and we do know that the amount of time that takes to get to 10% of its initial charge is 2.0 milliseconds. And let's add the capacitance here. The capacitance is 1.0 microfarads. So let's also go ahead and write down the equations that we have that involve charge as a function of time. So charge as a function of time is based on, this is going to be very simple, I think, because I could see right now that we could use this first equation. Here's our charge as a function of time expressed as the initial charge on our capacitor plates. We have time in it, and then we have the product RC. Now the product RC we call the time constant, and it has units of time. Just for completeness, I'm going to go ahead and write down our other two equations. The equation for the potential difference on the capacitor plates is given as Q naught over C e to the minus T over RC, and an expression for the current in this loop being equal to Q naught over RC e to the minus T over RC. Now, our goal is to find what value resistor. So let me write R equals question mark because we don't know that. So we have to find the value of the resistor that will discharge this capacitor to 10% of its initial value. And I see that we pretty much have everything we need, I think, to solve that from this first equation for charge as a function of time. So I'll start with this first equation. So we know that there's at some time t, our charge on our capacitor plates is 10% of its initial charge. So really, the only thing we don't know in this expression is the value of the resistance. And that resistance is in the exponent. So we're going to need to pull that out of the exponent. And how I'm going to do that is I'm going to just take the natural log of both sides. So we have the natural log of 0.10 is equal to the natural log of e to the minus t over RC. By writing that as a natural log, or by taking the natural log of both sides, we're able to drop down the exponent, minus t over RC, natural log of e. Natural log of e is just equal to 1. And we have now, and let's just rearrange this a little bit. We have RC, and actually, let's do this. We'll just multiply everything through by an R over the natural log of 0.10. So when we do that, the left side of our equation is equal to R, and the right side of our equation is equal to minus T over the capacitance times the natural log of 0.10. Now, this would give us our resistance as a function of time, or our resistance. We know what the time is. The time is 2 milliseconds. So we'll say 2.0 times 10 to the minus third seconds. And that's a minus sign in front. And then we know the capacitance. It's a 1 microfarad capacitor. So 1.0 times 10 to the minus 6 farads. And then we have the natural log of 0.10. Okay, I must have pressed the wrong key and it totally erased all of that work, but I think I remember what I just wrote down. So let me just write it down here. I think it was minus 2.0 milliseconds. So 2.0 times 10 to the minus 3 seconds. And that was over the capacitance, which I think was 1.0 microfarads. And natural log of 0.10. I'll go ahead and put this in my calculator. So that is 8.7 times 10 squared. So that looks to be about an 870 ohm resistor. But I'm going to do a unit check, because if my units don't work out, then I know I made a mistake somewhere. I see that I have units of a second per farad, and I'm not familiar with what seconds per farad is. So let's do a quick unit check. Ooh, that should have been resistance right here. I was thinking that was time. I have a second per farad, and I honestly don't know what a second per farad is, but I think it's always good to do a unit check to make sure we didn't make any major mistakes. And that was a good catch, is that it should be ohms. So let's do a second per farad. Now, how I will do a unit check for farad is I know that when we define capacitance, we said that capacitance was the ratio of charge per potential difference. Well, I know charge has units of Coulomb. Potential difference has units of joules per Coulomb, right? So this is and I'll just write C squared over joules. I also know, and let me do this slightly different way. I know from Ohm's law that resistance is potential difference over current. Potential difference is a joules per coulomb. Current is a coulomb per second. So this should be joules a joule second per coulomb squared, if I did that correctly. And that works out to be the unit of resistance. And remember, the unit of resistance is called the ohm. But this ohm, let's see. So I see that I have a farad because remember, we said a coulomb squared over a joule is a farad. So notice I have a reciprocal of joules over coulomb squared. So this is a second per farad. Yes, the units work out. Since the units work out, I feel pretty confident in saying that we got the answer, 870 ohms.